Hello, this is Jens from NG40. The topic of our video is NG40 vRAN emulation inclusive user plane injection for EPC verification. I'm going to show you how to emulate a 4G access network and how to inject user plane traffic from external sources. The application we use today, I minimize this window, is called SpeedTest Mini. So our application client is running on Firefox, and we want to reach a server with application called SpeedTest Mini. We have here this application 5 times, and we will later attach 5 UEs, and for every user we will start traffic from one of these applications. This SpeedTest Mini is my application of choice. Of course, you can replace SpeedTest Mini by any other application. First, I will introduce the NG40 and its modules, and then I will briefly explain the network topology that we are going to use. We see here on this picture 4 modules. First, we have as a basis a hypervisor, KVM for instance, and on top of the hypervisor we have 2 virtual machines. One virtual machine is our 4G access network emulation, and another one is any app that we want to use for the user plane traffic. The 4G access network emulator is controlled by a graphic user interface, which we see here. Because this application is running on an hypervisor and we emulate the UEs and we emulate the inode Bs, we don't have here a real air interface. And this application is running on off-the-shelf hardware. This means depending on the hardware we choose, different kind of topologies and different user plane traffic can be generated. We can start with a small laptop, or we can also use a high-performance server. For instance, a NUMA server with 2 processors and 18 cores each. Depending on the performance of the hardware, it is possible to emulate up to 2 million UEs, up to 20,000 inode Bs, and up to 8 million user plane bearers, EPS bearers. When it comes to user plane traffic, then it is possible to generate up to 8 gigabit per second with one server. We can cluster different kind of servers, which means if 8 gigabit per second, if this traffic is not sufficient, then it's possible to use another server and increase the user plane traffic accordingly. Now let's come to the application. On the left hand side we see the NG40 with the modules, and here we have 2 interfaces, S1, S1U, and with these 2 interfaces for control plane, user plane traffic, we are connected to our device under test to the EPC. The EPC itself again is connected via SGI interface to our server where this application SpeedTest Mini is running. The IP address we use is 12.1.1.1. Please remember this IP address because we will use this IP address later. And we also have 2 Wireshark applications running. One Wireshark is running on the S1, S1U interface. I have already filtered on the S1AP and the GDP protocol, and the second Wireshark, I clean it, is on the SGI interface. Now we will perform the following 5 procedures. First, we start a ping, and we will activate the vRAN from the GUI. Then we will perform an attach. Next, we will inject the user plane traffic. Then we will observe the user plane traffic on our Wiresharks, and last but not least, we can perform post-analysis of the traffic. Okay, let's start. Here is our application, and we start a ping to our server 12.1.1.1. We see the ping is not working, and if you look, destination not reachable, and if you look here on our Wireshark trace, we see there is no ping, even not a ping request. Okay, that will change soon. I will now connect to our server. The application is called tvm-vRAN1, and we will activate. So let's have a look what has happened on the Wireshark. Okay, now we see here on the S1 interface 5 setup requests and 5 setup response messages. Also, we see here already echo request from the S1U interface. Wonderful. We have here 5 setup response messages and no setup failure, which means the topology, the virtual RAN is activated successfully. And we see that we have here now 5 macro init Bs. So identifiers are 10, 20, 30, 40, 50. In other words, we have now a virtual RAN activated with 5 init Bs. Now we see still that the ping is not working. So let's go back to our graph user interface. We will now select a test case, and this test case is called TC-attach bridge. Before I start this test case, I go here in this tool button, because here I can choose several parameters. Today we will just use this parameter number of user. This will increase to 5. So that means we will now perform an attach for 5 UEs. Start. Let's have a look on our Wireshark, and now we see here one attach for this IMSI. The UE gets this IP address, another attach, attach number 3, attach number 4, and attach number 5. And we see also that the ping is now working. Now, after the attach, it is possible to generate traffic from our user plane client, send it over the access network, over the EPC, up to the server, and then we get a response. Yeah, we can double check this on our application. We see the ping is now working. So I will stop the ping because I don't want to have any impairments from the ping for the other user plane applications from the SpeedTest Mini. So the ping is now stopped, and here we have our SpeedTest Mini application. So if we go on the second Wireshark, then we should see the ping as well. That is a Wireshark from the SGI interface. Also here the ping is visible. Okay, I will clean the Wireshark again. This is the Wireshark from the S1. Sorry, from the SGI interface. This is the ping from the S1U interface. I will clean this as well. And now we can go back to our application and start the speed test. So I have here 5 of these applications because we have attached 5 UEs. Every UE gets one default bearer, and over this default bearer now we will send the traffic. So that is pretty simple. We just have to click on this button here, begin test. The speed test now is activated. We also see here now TCP messages between our application client and application server. And now we see here the traffic running. So we have here 5 applications. On one download was 50 megabit per second. Here we have 18, 21, almost 10, here 18. So if we look on this, then in total we have here more or less or even more than 100 megabit per second download traffic. The same for uplink. Again, it's almost or even more than 120 megabit per second upload traffic. Okay, ladies and gentlemen, this was the first part of our video. Thank you very much for your attention. There will be a second part where we later will analyze the traffic. Thank you very much.